Energy is not a thing. It's not something that you can put in a tanker and ship to New York City. Energy instead is a property of things. It's something that is possessed by things. In this sense, it's something like color or mass. You can't have a jar of green or a bucket of grams. They're not things. They're properties possessed by things. And energy is like this. Surprisingly, we still have no real way of expressing what energy is. Energy is such a fundamental concept that you can't explain it really in terms of other things. It's not made of something else. It's not constructed of other pieces. It is a bottom-level fundamental thing in physics. Energy actually appears in many different forms. There's thermal energy and gravitational energy and electromagnetic energy and mass energy. We also have some principles about how energy behaves. And the most important one of these is also the most simple. We believe that energy is a perfectly conserved quantity. Whenever anything happens in the universe, the amount of energy which was present before it happens is exactly the same as the amount of energy that is present after it happens. The form of that energy may change from one kind to another in such a process, but the total quantity of energy never does change. So the ultimate source of almost all the energy that we use on the Earth is the sun. The sun pours radiant energy, electromagnetic energy, down on the surface of the Earth at a rate of about a billion joules per second, a billion watts. This rate is very large, and it's what, of course, keeps the Earth warm, even though we're otherwise surrounded by a very cold interstellar medium. That energy that the sun pours onto the Earth then gets sometimes stored up in many different forms. Plants do this very directly. They harness the energy of the sun through the process of photosynthesis and use it to construct large, complex molecules that store the energy in their structure. What we do as animals is to consume plants, and sometimes other animals, which have stored this energy in the form of chemical bonds, and we release it as it flows through us. In that process of releasing the energy that's stored in those bonds, we spread that energy out and can use that flow of energy in order to accomplish what we want, to move around, to teach physics lessons, whatever it is we want to do with that energy. I think the most important thing to keep in mind about what the conservation of energy tells us about what we do and how we act is that the total quantity of energy in the universe is a fixed thing. And what we're really doing when we say we're using energy is not that we're burning it up so that it's lost. That can never happen. Energy is conserved. What we're doing is we're transforming it from forms in which it's held together in one place, it's stored up, and then we're releasing it. And in the process of releasing this energy out so that it spreads out through the world, we can take advantage of that flow of energy through us or our computer or our car. That flow of energy can make something happen along the way. So we're always taking energy from a more compressed form, allowing it to flow out into a more spread form. When that happens, it's a one-time process. It's very difficult, in fact impossible, to bring that energy back together again without cost. And so that's a quick explanation of what the conservation of energy is about and why it's such a fundamental thing in the science of physics.